This video will show you how to perform analysis step 1 to come up with a initial voltage based on your data from the charging up, charging down calculator activity. So what we're going to do here is we're going to collect some data as shown in the procedure, and the goal here is for us to come up with an equation that fits the form y equals VE to the negative kx. That's what we're going to try to do here, is we're going to come up with that model. But to do that, we have to come up with some numbers. And if you look here in the middle of the screen, you'll see that the equation y equals VE to the negative kx is shown. And right underneath that, it says y represents the voltage across the capacitor at any time x. So y represents voltage and x represents time. And the V that we're looking for is the capacitor's initial voltage. That's what we're going to try to find here. And you can find that from your data. So please make sure that you've completed the procedure steps 1 through 8 to come up with your data, and have your calculator handy so that you can take a look at your data and come up with the answers that you need. So find your calculator. I have mine at the bottom of the screen here. I've chosen to use here. You should have a graph that looks something like this on your calculator. Now my calculator here looks different from yours because it's not the big yellow guy that we use in class, but all the buttons are the same. If you look at the buttons on your calculator, you'll see that they're all the same buttons, all in the same place, just like what I have here on the screen. It's just that this calculator on the screen looks a little bit different. But I chose this one because it has all the same buttons. So if you look at your analysis part 1, analysis part 1 is on your 3rd page. And analysis part 1 says we're going to use a curve of the form y equals VE to the negative kx to the data. We're going to fit that equation to the data. But we have to use the graph and find the y-intercept and move the flashing cursor to it to read the value. So let's go to your graph, and we're going to use the trace function to be able to trace and find any coordinates of any points that are on your graph. And the trace button is up here at the top row of buttons. Look for the one that says trace. And if you choose that, you'll see that a cursor pops up on the screen. This one just happens to be at x equals 0, y equals 8.36. If you want to find any other coordinates, you can use the right and left arrow buttons to move that cursor wherever you'd like. And in this case, we want to find the y-intercept. The statement asks us to find the y-intercept and move the flashing cursor to it to read the value. And the y-intercept is where the graph meets the y-axis. And the y-axis is the uppy-downy axis. Technical terms there. Some people just call it the vertical. And you want to move the cursor so that it is on the y-axis. And you'll know when you get there because you'll see that x equals 0 down here at the bottom. When x equals 0, that means you're on the y-axis. That means time is 0. And you see over here the y says 8.36. And since y represents voltage, that means the voltage at time 0 is 8.36 volts. I chose 8.36 just because is even. I've rounded it. We have a 9-volt battery. I just picked 9 volts and subtracted a little bit of voltage at the beginning. You might have something around 9. You might have something in the 4 range. It makes no difference. I just made this one up so I could make the video. So whatever this value is down here for y at the x-intercept, or I'm sorry, the y-intercept, is what's going to be considered your initial voltage. And that's your initial voltage V that you'd use in your data table. So please make sure you get the initial voltage V in there. And I'm going to make a video for analysis step 2 coming up. Finish up your V right here, and then take a look at the next video on how we can graph the model that you're going to come up with.